Hey, Algebra 2 honor students, this is going to be the start of Unit 15. We are on day 1. Today we're talking about linear trig equations. And that's what Unit 15 is all about, is solving trig equations. So if we understand linear trig equations, we're going to build throughout the week to quadratics and then talk about other frequencies, a lot more to come in this unit. But the first initial step here is to isolate the trig function. So if the trig function, whether it's sine, cos, tan, or otherwise is not alone, we want to get that trig function alone. And then we're going to draw triangles in the appropriate quadrants, or we're going to use some graphs to help us determine our answers. Now, when I say appropriate quadrants, what I mean by that is based on the ratio that we're looking at, if it's positive or if it's negative, that tells me which quadrants to draw triangles in, all-star trig class. We'll talk about that, of course, as we do some specific examples. Step 3 is to find the reference angle and then all solutions that are necessary. When I say all solutions that are necessary, you're going to see on the homework that's associated with this lesson that sometimes we change the interval over which we accept answers. So for this first one right here, where we have 2 sine x plus 1 equals 0, we're going to solve over the interval where I want all solutions for x from 0 to 360 degrees. So that's the interval that we're setting to be able to find all of our solutions. But you'll see on the homework tonight, maybe I want only the solutions from 0 to 90. Maybe I just want the quadrant 1 answers only, if they apply. All right, so let's actually go ahead and try this first example here. 2 sine x plus 1 equals 0. The first step that we would take is to isolate the function sine x. So I'm going to subtract 1 to the other side. And then next, divide by 2. So sine x is equal to negative 1/2. That's a pretty quick, easy step to get sine alone. Once sine is alone, now I want you to jump right into all-star trig class to think about in which quadrants would sine of an angle, because that's the answer, by the way, it's an angle that gives me the ratio negative 1/2. Which quadrants would sine give you a negative answer? Well, the quadrants where sine is negative are quadrants 3 and 4. Everything's positive in 1, and sine is definitely positive in 2. So what that tells me is I'm going to draw 2 triangles. One of them's in quadrant 3, one of them's in quadrant 4. It's the bottom half of the bow tie here. Now for sine, we know we can label some sides. We can label that the opposite is negative 1, the hypotenuse is 2. Same thing for the triangle in quadrant 4. And I'm hoping this is starting to look like a recognizable triangle to you. Here's the angle x in question. And when you have the opposite of 1, the hypotenuse of 2, isn't the adjacent side radical 3? Now in quadrant 3, it's technically a negative length, or just because we're going to the left, I label it negative. In quadrant 1 or 4, it's positive. Not a huge deal if you forget those labels, but here's the main idea. What is the reference angle, right? The reference angle across from a 1 in that special triangle is 30 degrees. Okay, going back to the good old reference triangles that we started with in Unit 13. So if the reference angle is 30 degrees, how do I get my 2 answers? Well, one of my answers is in quadrant 3. So in quadrant 3, I go halfway around of 180, and then you add on that reference of 30 to get a total answer of 210. What do I do if I'm in quadrant 4? Well, quadrant 4 is that almost full circle, right? Except I'm subtracting out the reference of 30. So full circle is 360 minus 30, which is 330 degrees. These are the 2 answers. The 2 solutions are 210 and 330. And you can check those answers if you'd like by typing it into your calculator. You do have to make sure that if you were in radian mode at all in Unit 14, that you want to switch it back over to degree mode to check today. Okay, but now that I have that switched over, what is the sine of 210 degrees? Is it negative 1/2? It sure is. Same thing for sine of 330. Hopefully you get negative 1/2. So if you want to check in on anything today, you can certainly type it into the calculator and confirm the results that we expect. All right, let's move on to, for example 2, taking a look at 6 cosine x minus 2 equals 3. We're going to solve this one over the same exact interval where x is an angle from 0 to 360 degrees. So to get started here, same idea. Let's isolate the function cosine x this time by adding the 2 to the other side. So 6 cosine x now equals 5. And therefore, cosine of x would equal 5/6. Okay. Now that I have this established, I want to ask myself the same thing that I asked in number 1. Which quadrants would I expect answers in? All-star trig class. Which quadrants am I going to get answers in? Well, this time we're looking at a ratio for cosine that's positive 5/6. So in which quadrants would I establish a ratio for cosine that's positive? The 2 quadrants where cosine's positive are 1 and 4. They're all positive in 1. Cos is certainly positive in 4. Well, based on that, I'm going to set up a triangle in quadrant 1 and then a triangle in quadrant 4. So we got the right half of the bow tie this time. All right, now that I have that established, let's go ahead and maybe do some labels. Cosine is adjacent over hypotenuse. So I'll put the adjacent of 5. The hypotenuses are 6. Okay, here's the angle x that I'm looking to find, but here's the deal. When you have an adjacent of 5 and a hypotenuse of 6, although Pythag will get me this last side, I certainly wouldn't know exactly what this angle is because this is not a special triangle. The special triangles are the patterns for 30, 60, 90 like we had up here, or 45, 45, 90. So if this is the case, that we don't wind up having a special triangle here, we're going to default to using the calculator to get the reference angle. And on the calculator, you're going to type in cos inverse of 5, 6, right? And that's how you would solve for x. You would take the cos inverse of both sides. So the cos inverse of 5/6. Let's see what that winds up giving us here. So we are going to have to round this somewhere. Cos inverse of 5, 6. Make sure you're in degree mode, otherwise you won't get the right answer. Let's go to the nearest 1/10 of a degree. That would be 33.6 degrees. Okay, that's the reference angle, 33.6. So what do I have to do? I have to take that reference angle of 33.6 and I have to get a quadrant 1 answer and a quadrant 4 answer. Well, in quadrant 1, the reference angle is your answer, 33.6 degrees. How do I get the quadrant 4 answer if this is a reference of 33.6? It's the same rule that I used up in here for number 1. You're going to take 360 and subtract 33.6 degrees. So if you do 360 minus this answer right here, you wind up getting 326.4 as the other solution here. Okay. And if you were to check this, we're not going to get exactly 5/6 as our answer because we did round these angles, but we should get something pretty close to 5, 6 if I do cos of 33.6 degrees and similarly cosine of 326.4. Okay. Well, you know what? Let's do something with tan in it. Let's go on to tan. All right, so for number 3, let's solve the equation. 3 tan x plus 8 is equal to 6. Okay, and we'll do this over 0 to 360 as well. Sometimes, you know what? I'll just write it like this. Okay, so the domain that we're solving over is including 0 and including 360. All right, so let's see. Just like the others, let's isolate tan first. So 3 tan x is equal to 6 minus 8, which is -2. And therefore, tan x equals -2/3. Okay, same idea as the others. Next thing, once you get tan alone, is deciding what quadrants should I get answers in. Well, for tan, we're looking at opposite over adjacent. And when tan is negative, we're in either quadrant 2 or quadrant 4. Okay, so that's where you're going to draw your reference triangles, quadrant 2 and quadrant 4. Tan, like I said, is opposite over adjacent. Notice how when I label, I put the negative in the correct location. -2/3 could be the same thing as 2 over -3. You know, maybe not a huge deal there. But once I have all that labeled, here's my reference angle x. Is this a special triangle where the opposite is 2 and the adjacent's 3? Not quite. So we are going to need the calculator again for the reference angle here. But I want you to make a really special note about the reference angle for this one. When you type in reference angles on your calculator, you should only ever do tan inverse of +2/3. So why am I ignoring the negative? Well, the negative is going to give you a weird result on the calculator first and foremost. But the reason we get to ignore the negative is, remember, the negative just tells you which quadrants your answer should be in. So we've actually already used this negative by deciding that we get quadrant 2 and quadrant 4 answers. But now to get the reference angle, this angle x right here, I want to do tan inverse of positive 2/3. It's kind of a big deal, so make sure you pay attention to that if that ever comes up. Tan inverse of 2/3 is 33.7 degrees. So this is your reference angle, 33.7. Now, is 33.7 an answer to this, a solution to this equation? The answer is actually no, because we know we have to get a quadrant 2 and a quadrant 4 answer as my results. We haven't done quadrant 2 yet, but if this angle is 33.7, the quadrant 2 angle, this one right here, is going to be take a half circle of 180 and subtract the reference 33.7. So 180 minus this reference is 146.3. So 146.3 is the quadrant 3 answer. We've already done quadrant 3, or actually quadrant 4, sorry. So that's 360 full circle. But subtract out the reference, 33.7. So 360 minus, just make sure if you're going to use the calculator, you actually take the reference angle and subtract it. So that's 326.3. So those are the two solutions to that linear trig equation with tangent in it. Okay, we're doing pretty good here. Moving on down the line. Let's do one that looks like this. 2 sine x plus 2 is equal to 0. We'll just keep it 0 to 360 for now. Okay. So if I want to solve this equation, 2 sine x plus 2 equals 0, we're going to first subtract the 2 to the other side. 2 sine x equals -2, and then we get sine x equals -1 when I divide by 2. We jump right over here, all-star trig class, sine is negative here and here. I went really fast through that, but maybe after 3 examples, you're in the same place as me, that you can jump to that conclusion as quickly as I have. All right, here we go. Sine in quadrants 3 and 4. Opposite over hypotenuse. Now, if it's not a fraction, you can put it over 1, right? Like this. All right, so if I label those sides in this way, you should be a little questioning of what's happening right now. I hope you are. Have you ever seen a right triangle where the opposite of x and the hypotenuse have the same length? And I'm hoping you're jumping out of your chairs right now saying, no, that looks crazy to me. Okay, so it turns out that this is not a reference triangle case. However, this does have solutions. 2 ways in which you can get your answers. One of them, this is a value that comes from the unit circle. The other way to look at it is graphing the sine function. We know how to do both of these, so I'm going to allow you to choose which method you kind of like best. But on the unit circle, we know that sine of x, actually, you know what, let me call it theta just so you don't get confused. Sine theta equals y on the unit circle. So when is y -1 on the unit circle? We think about all the coordinate points on the unit circle. The only time the y value is -1 is down here. So what is this angle where we are? The answer to this, the solution to this equation is x equals 270 degrees. It has one solution. Let's see if you like the graphical solution better. If you graph one cycle of sine from -1 to 1 for the range, the graph would look something like this, these key 5 points. Okay, so what we're looking at is when does the sine curve hit -1? And the only time that happens is when the angle is 270. So if you remember that, based on the sine curve, that's great. You have to be really confident with either of these techniques. I tend to probably stick with unit circle a little bit more than I do the sine and the cosine graphs, especially when you get into examples like tan. You know, graphing tan might be a little bit tough at times. So I like unit circle, but both are clearly acceptable ways of showing work to get the answer. It's only one solution. It only happens to be when x equals 270 degrees. Okay. All right, a couple more examples to finish up today. We've got 2 more that are going to look a little funky, but you're going to like it. Ready for this? All right, number 5. Let's solve log base 2 of cosine x equals 0. What? Log base 2 of cosine x equals 0. Where did logs come into play? How did those sneak their way back into what we're doing with trig? Okay, well, here's the good news. We know how to solve log equations. If all the logs are condensed, which they are, this has been a while, but we're going to jump right into it. You can convert this to exponential form. Convert to exponential form. So remember, exponential form would say that 2 to the 0 equals cosine x. Cosine x equals 2 to the 0. All right, and if 2 to the 0 we know is 1, now I want to figure out when does cosine of x equal 1. I'm going to give you a little bit of a hint. Before you jump right into triangles like we usually do for all-star trig class, this is going to be the same issue we ran into in the last example with sine. If the adjacent and hypotenuse are both 1, it's not an example of looking at triangles. This is going to be an example of either unit circle or the graph. I'll do both again. Here's what unit circle would look like. Now remember, on the unit circle, cosine theta this time is x. So I want to know, when does the x value equal to 1? So the x value is 1 here and nowhere else, right? Otherwise, the x value would be 0, -1, and 0 down here. So the only solution is that x equals 0 degrees, and then 360 would be a solution as well, I guess, technically, if I was including both. If I said, hey, graph this and only find solutions from 0 to 360, sometimes this is the way the domain is written, where 0 is included, but 360 is not included, then I would have crossed off 360, okay, and said only 0. Since 0 and 360 are in the same spot, we usually don't include both. So watch out for that in the way the interval is defined. This would only give you 0 as a solution. But thinking about what the graph looks like, cosine has these key 5 points. Okay, so when does cosine of x equal 1? It equals 1 right at the start at 0. And again, also at 360, we just got to check out this interval and see which of those solutions do we want to accept. All right, so I'll just say x equals 0 for now. I know I didn't define this right away at the top, but that is typically what we'll see in relationship to these types of questions. Okay. All right, last but not least, let's think about maybe some reciprocal functions, okay? So let's do, for our last example today, 2 secant of x equals -7. 2 secant x equals -7. All right, for this example, quickly divide by 2 to get secant x equals -7/2. And when I'm looking at this equation, at this point, it's certainly not going to be a nice triangle. I don't typically have sides in a special triangle with, opposite of 7 or the adjacent and hypotenuses being 2 and 7. So what you're going to do is switch it to what it's the reciprocal of. This is the reciprocal of cosine x. So what I now know is that cosine equals -2/7. That's going to be a little bit easier for me to work with. So all-star trig class would tell me that cosine is negative in quadrants 2 and 3, because cosine's positive in these quadrants. All right, so here we go. We need the left side of the bow tie this time. Adjacent is -2. Hypotenuse is 7. I want to find that reference angle, x, right there. To get the reference angle, to reiterate from something we talked about earlier, you're going to do cos inverse of +2/7. You will never, ever, ever type in cos inverse of a negative or any inverse function of a negative. It's going to give you results that you're not very happy with. All right, cos inverse of 2/7 is 73.39 ... So let's say 73.4-ish degrees. Now remember, that's just the reference angle. We need a quadrant 2 and a quadrant 3 answer from that. In quadrant 2, we're looking at 180 minus the reference. And in quadrant 3, it's just 180 plus the reference. So let's see what we get as a result. When we do the following subtraction and addition, 180 minus the reference is 106.6. Sounds like a radio station. 180 plus the reference is 253.4. Okay, so your two solutions are 106.6 degrees and 253.4. And there we have it. Okay, so we'll do some, of course, some more practice next time we're in class with some linear trig equations, so a little bit more to come. But that's, I think, good for our first day of solving equations here. If you have any questions, let me know. Have a great day.